Yeah. Okay, go ahead.
Oh wait, it's rolling?
Yeah, it's going.
Welcome back. This is lesson 5.2 homework. You know, just the usual math.
Just the usual.
Yeah.
All right. This is number 1 of lesson 5.2. Simplify the square root. Assume all variables represent positive numbers. We don't have variables here. If the square root is already simplified, so state, which means just say that it is. Okay, so we're either going to choose to simplify it and rewrite it, or we're going to say it's already simplified, we can't do anything else. For example, if this was the expression they gave us, is there any way we could simplify that square root? No. So we would choose the expression is already simplified. Is there a way to simplify the square root of 12? So there are 2 questions we need to ask ourselves. Number 1, is this a perfect square? Can you square root it and get a whole number?
Yes.
Okay, what is it?
Wait, hold on.
Somebody give me an example of a number that's a perfect square.
2, 4,
4, what's the square root of 4?
2,
Good. Somebody give me another example of a perfect square.
64,
Good, what's the square root of it?
8,
Good. Somebody that's not Zach, give me a number that is a perfect square.
6,
16. What's the square root of 16?
4,
Good. Give me another one.
6,
What's the square root of 6?
2. I don't know.
Remember that a perfect square,
This one is
a perfect square isn't a number that can be divided by 2 or divided by 3. It's a number that can be where you can find the root of it. The root is multiplied times itself to get the number. So you would need a whole number to multiply times itself to get 6. Is there a whole number that can?
14,
What?
14, 7.
So 14 divided by 2 is 7. 2 times 7, that's not the same number. What?
144.
144. Emily, what's the square root of 144? What number times itself will give you 144? Yeah, never mind.
11?
No, that would be 121. What? 81. The square root of 81 is 9. I'm going to give you another one, Emily. What's the square root of 49? Good. What's the square root of 25? Good. What's the square root of 26? Exactly. I don't know either. It's something that's like a little higher than 5 because 26 is a little higher than 25. But if I put the square root of 26 into the calculator, it's 5.0990195514, and it just keeps going and going and going. There's not even enough space in the calculator to tell me all of those decimal numbers. There's not enough space in the world to tell me all of those decimal numbers. It's irrational. So is 25 a perfect square?
Yes. Yeah.
Yes, because the square root is a whole number 5. Is 26 a perfect square?
It can be.
Is 26 a perfect square?
No. Has to be a whole number.
No, because the square root of it is not a whole number. Is 27 a perfect square?
No.
No. Is 28 a perfect square? Is 29 a perfect square?
No.
Is 36 a perfect square?
Yes.
Why?
6 times 6.
Very good. Is 37 a perfect square?
No.
Is 38 a perfect square? If I keep going, where's my next perfect square?
49.
49. 7 times 7. 8 times 8 would be 64. 9 times 9 would be 81. 10 times 10 would be 100. 11 times 11 is 121. 12 times 12 is 144. That's why I said, what's the square root of 144? I'm only giving you guys perfect squares of multiplication facts that we should have memorized. Okay, all of that to say that if you're given something like the square root of 3, the square root of 5, those cannot be broken down. So let's look at this, the square root of 12. Is it a perfect square? That's the first question we're going to ask. Is it a perfect square? Can we just punch it into our calculator and get a whole number? No. The second question we ask is is there a perfect square inside of it? If I open up that 12 and look at the factors of 12, would I find a perfect square in there?
Yes.
Yes. What's that perfect square?
144.
No.
12?
The factors of 12. If I open up the 12, is that gonna, are 6 or 2 perfect squares? No. You're not? Can you guys give me other factors of 12? Yes, 4 and 3. 4 and 3. Is 4 a perfect? Is 4 a perfect square?
Yes.
Yes. So that's the second question we asked to say, can it be simplified? We can rewrite the square root of 12 as the square root of 4 times 3. Can either of these be simplified? The square root of 4 can. What is it? 2. Can the square root of 3 be simplified? No. So what's our answer? Yeah, 2 times the square root of 3. So this would be 2, I'm just drawing an arrow here, 2 times the square root of 3. I don't have to show this multiplication dot or parentheses because they're right next to each other, implying multiplication. Okay? Two times the square root of 3. Oh, did you get a different number?
No, I have the same number except I think
Did I press record? Yeah, I did, right?
I was making sure because I have to have it on my keyboard and it's being
Okay. All right, number 2. Simplify the square root. Same thing. I give a lot of these easier ones for homework. All right. The square root of 54 can be written as, I don't know, 54. That's a weird number. 6 times 9. Very good. Can either of these be square rooted? Which one? 9. What's the square root of 9? 3. How do we write this? Oh, well, let me break this down. Or let me keep going. The square root of 6. Is that a whole number? Is the square root of 6 a whole number? Can it be simplified? No. If I were to break this down into factors, what would the factors be? 2 and 3. Are either of those perfect squares that can be square rooted? No. So that's as simple as that can get. So how do we write it?
3 times 6.
Yep, 3 times the square root of 6. Or 3 rather than 6. Use the product rule to simplify the radical. Okay, so we have a 3 on the outside. That's not being square rooted or cube rooted or anything like that. But then we have the square root of 40. Is 40 a perfect square? Can we get a whole number by square rooting it? We can? What's the square root of 40? Yeah, if you're ever not sure, just put in your calculator. 40, and then hit the square root button.
It's an even number.
I know, you're thinking, well, it can be divided by 2, but that's just an even number. That has nothing to do with perfect squares.
Wait, for this one, you have to figure out, like, you use times, like, for minus 154, you
4 by 54?
Yeah.
Wait, do you have these numbers? Okay, so let me do this one. If you follow along with what I do, you should have learned enough where you can do that one on your own. Okay, so 3 times the square root of 40. What should I do to 40 since I can't square root it? What should I do to it? Yeah, we'll break it down. We can do some prime factorization. Or we could keep it, yeah, we could do some prime factorization. Let's see, this is where we're gonna have to like really do prime factorization, which is, if you haven't had my class yet today, we're going over this today. So let's try 20 and 2. 2 is a prime number, so I'm gonna circle it, it can't break down anymore. 20, I've got 10 and 2, another prime, and then 10, I've got 2 and 5, prime, prime. So I can rewrite the square root of 40 as the square root of 2 times 2 times 2 times 5. Now, if I have 2 times 2 times 2, I can rewrite that as either, I'm going to do this, 2 times 2 times 2 can be rewritten either as 2 cubed or 2 squared times 2. So if I write it as 2 cubed, it looks concise, but I can't find the square root of 2 cubed. So I'm going to choose not to write it like that. I'm going to choose to combine these to be 2 squared, and then have this extra times 2 on the side, because I can find the square root of 2 squared. So I'm going to break this down and separate this into the square root of 2 squared times the square root of 2 times 5. So I have my 2 times 2 times 2, but I joined this 2 times 2 together, and I let this 2 just simply multiply times 5 in the square root. So why did I join these two 2's together, 2 squared? The square root of 2 squared, isn't that 2 to the 2 over 2 power?
Oh, where'd you get the 2?
Because if there's no number here, if there's no index, no root, it's an invisible 2. I like to make them show up because it helps me see my rational exponent. Because if I use my root or my index, it's called both things, if I use that as my denominator and my exponent as my numerator, I can write this as 2 to the 2 over 2 power. 2 over 2 equals 2 over 2. Emily, I'm not sure why you're using your calculator right now.
Sorry.
Do you have your notebook out? Yeah.
If mine's thing, if mine's 27, and then
Well, let's do this first, and then we'll figure out yours, okay? So, what's 2 over 2?
1.
Yes. 2 to the 1 power is
2.
2. So what we did was we were able to free these sweet little birdies, the 2 times the 2, we freed it from its radicage. This is a radical cage. That's what I call it. What?
Would it be wrapped into a wrapped?
No, it's radicage. Radicage. Because it's radical. So I call it a radicage. That's just my little Nicky name for it. Okay, I was able to pull these out and free them by simplifying them, because 2 times 2 is 2 squared. The square root of 2 squared is 2. Fly, little birdie, join your friend out here. The 3 times the 2. So this is going to spread its wings and fly from its radicage. That means I'm done with these. They have flown the nest, and we square rooted them, so we're only pulling out a 2. So the 3 times the 2 will be on the outside. Is there any way to break this down? How? Okay. Is there any way to break this down? How? Okay. Is there any way to break this down? We can multiply them. Then we can break them down. And then we can multiply them again. We can break them down. We can keep doing it so we don't have to do any of the other problems. And do it forever. No? Okay. So since I can't do anything, the simplest way I can write this is radical 10, and that's all I can do. But I have my 2 times my 3 on the outside of the radicage. What's that? 3 times 2 is 6 times my radical 10. So that would be 6 radical 10. We can't break it up anymore. So, you guys ever hear of the Smashing Pumpkins?
Yeah, I've done
It's a band from the 90s. Despite all my rage, I'm still just a rat in a cage. Despite all my rage, I'm still just a rat in a cage. Like the way that I'm singing, that's actually how his voice sounds. He has like the worst voice. But people loved the Smashing Pumpkins in the 90s. I don't know why, I didn't like them. But I always think of that song because this number 10 can't break from its radicage. So it's like, despite all my rage, I'm still in my radical cage. Despite all my rage, I'm still in my radical cage. So this birdie flew away and was able to break free of the radical cage. But this one, despite all my rage, I'm still just a radical cage. Okay. Anyway, that's how you solve that. And that was a little 90s music trivia for you. All right. So did you guys have a question on your numbers?
Yes.
Are you having trouble breaking yours down?
Yes.
Okay, what's yours, Emily?
It minus 9 with the radical
27? Okay. What can 27 break down to? 9 and 3, very good. So I'm going to rewrite this to be 9 times radical 9 times 3. Or square root of 9 times 3. It's freed from its radicage. The radical 9, or the square root of 9, is 3. Fly, birdie. Join out there. So that would be 9 times 3 on the outside. And just your measly old square root of 3 on the inside. Oops. Does that make sense? And this 3, you know what song he's singing? Despite all my rage, I am still in my radical cage. Despite all my rage, I am still just a radical cage. Emily A., do you have a question on your numbers?
No, probably just tell me.
Wonderful.
So you have that stuff in my head now.
Yay! You'll never forget how to do the radical cage. Write the following expression in simplest form. Okay, so we've got the square root of 3 squared times the square root of 11 to the 4th. I wrote them out separately so I can kind of evaluate them separately. Is that okay?
Yep.
All right. So let's remind ourselves that if it's the square root or if it's a radical cage that doesn't have a root, then it's an invisible 2 because it is a square root. So I like to do this on these kinds of problems. Make my square root show up with a 2 so that when I rewrite it with a rational exponent, it looks like this. 3 to the 2 over 2 power times 11 to the what? 4 over 2. The exponent is your numerator, and your index is your denominator. Now let's simplify these. 3 to the 2 over 2 is the same as 3, because it's 3 to the 1 power, which is 3, times 11 to the 4 over 2 power. What's 11 to the 4? What's 4 over 2? 2. So 11 squared. And 11 squared is? No, that's 11 times 2. Yep.
Wait, what happened? Oh, so my question was like, what happened to the 2 over 2 that it just turns to 1 and then
Yep. So 11, so that would be 121. And then just do 3 times 121, whatever the calculator says is that. 121 times 3, 363.
So the answer is just 163.
Yeah. And if all else fails, you guys can just do 3 squared in your calculator and get 9, and then do 11 to the 4th power in your calculator and get whatever that is, and then multiply them together, get whatever that is, and then square root it and get the answer. Like, you could also do it like that. It's not as much of a process as what I shared with you, but. All right, write the following product in simplest form. We're gonna break these down again. Spite on my rage, I'm still just riding cage. Okay, maybe I do like the Smashing Pumpkins after all. I'm gonna go ahead and start breaking down my numbers. Don't worry about the radical cages right now. I just want to kind of break down my numbers into all of my, I'm going to do prime factorization. I'm going to get all of my prime factors. So let's do 72. What do we have here? 8 times 9, 2 times 4, 2 times 2, and 3 times 3. Okay, and then I have 63, 7 times 9, prime, 3 times 3, prime, prime. And that's gonna help me kind of like just look at everything kind of in a row. So when I multiply these together, I can actually write them as the square root of, they can join together in a square root home. So that would be, my 72 would be 2 times 2 times 2 times 3 times 3, and then my 63 would be 3 times 3 times 7, so I'm going to write that out. 2 times, actually, I can actually write it as, with powers. 2 times 2 times 2 would be 2 cubed, right? So that's done there. And then 3 times 3 times 3 times 3 would be 3 to the 4th, and then times 7. So, let's see what can be broken from its radical cage. Now, the square root of 2 to the 3rd power. The square root of 2 to the 3rd power would be 2 to the 3 over 2 power. That doesn't really help me, does it? Can I rewrite 2 cubed as 2 squared times 2? Can I? Yeah. And if I do that, I can break this free from its radical cage, because the square root of 2 squared is what? The square root of 2 squared is what?
2 over 2.
Yep, 2 to the 2 over 2, which is 2 to the 1, which is 2. I'm totally fine with breaking it down into baby steps like that. We gotta get to a point where when we see this, and we have matchy-matchy, our index and our exponent, or our root and our exponent, if they match, they're gonna cancel out, right? If they match, they're gonna cancel out, and it's this number, the 2, the base, that's going to be freed from the radical cage, okay? The radical cage. So, the 2 squared gets freed by square rooting it, you get a 2. So that's gonna go on the outside of the radical cage. This 2, remember, because we had a total of 2 cubed, that's 2 times 2 times 2, we were only able to free the 2 squared. So this 2 stays. Despite all his rage, he is still in his radical cage. Okay? So we've taken care of the 2 cubed. 2 squared was freed, 2 stays. Now, 3 to the 4th, the square root of 3 to the 4th. What's that? The square root of 3 to the 4th. Ricky, can you do it?
The square root of 3 to the 4th.
Mm-hmm.
Wait, you mean like 3 times 3 times 3 times 3?
No, I don't mean that.
Is it 3 and 3?
Nope. Well,
Because
yes.
when you get 2 3.
Yes, it is. You're thinking about it in a different way, you little genius. But what I want you guys to do, the super easy thing where you don't have to multiply anything, is you take your root and you take your exponent and you put them in a numerator, denominator. I'm writing this song off the top of my head and it's really annoying, so you want to give me the answer, so I stop singing. So what would that be if I have a 2 index and 4 as my exponent? How would I write it with the numerator denominator?
4 over 2.
Thank you. 3 to the 4 over 2, which is 3 to the 2nd power, or 3 squared, which is 9. So, it's freed from its radical cage. The square root of 3 to the 4th power is 9. So 9 goes over here. It's free. Despite all my rage, I'm still just a radical cage. Okay? Can the 7 do anything to get out of the radical cage? No, poor little 7. So we've got the free birds and the radical cage. The birds in the radical cage.
That's it?
Okay, yep. So it's 18, radical 14. Woo! Dividing now. What I'll do is, we're not gonna finish this. You know what, actually, we're gonna pause this, okay? Here's what we're gonna do. I'm gonna give an extra day to turn this in, so you do not have to do the rest of it on your own. We will work on the rest of this tomorrow during class, and I'll extend the due date for everybody as well, okay?